Hello everyone, welcome back to my channel. Now we are going to start off with the course on MCQs on electrical machines. Starting off with question. Dynamic braking is very effective for. So the answer is it is effective for separately excited motors, that is option number B. Why? Because in separately excited motors, the direction of the field can be very easily altered by alternating the terminals of the field. Next. Dynamic braking is employed to brake both the non-reversing as well as the reversing drive. So the answer is C, that is both first and the second. Next, DC machine is a conduction machine, that is A. We know that DC machine has a direct contact to conductor and controlling of current is also direct. So it is mainly a conduction machine, that is A. Next, generators work on the principle of production of. So the answer is it is dynamically induced EMF. It works on dynamically induced EMF, whereas transformers work on static induced EMF. Next, induction motor operation depends upon, so it depends on the rotating magnetic field. According to Faraday's law, when a current carrying conductor is placed in magnetic field, it will experience a mechanical force. To get that mechanical force, a stationary conductor should cut the rotating magnetic field. We know that in order to produce a rotating magnetic field or RMF, it requires a three-phase symmetrical distributed winding and a three-phase supply to be given. So the three-phase current produce a three-phase flux in three phases and they interact and produce a net flux which is a constant, but it changes its axis, which is called the RMF. Next, find the number of poles required when the frequency is 50 Hz and the speed of the motor is 500 rpm. So we know that the synchronous speed is equal to 120 F by P, where F is the frequency, P is the number of poles, and N is the speed, synchronous speed. So just putting up the values, we'll be getting P is equal to 12. So answer is C. We know that the synchronous speed is defined as a speed with which the rotating field rotates for a standard frequency and for a given number of poles. Next. The sequence of induction motor is R by B, then the direction of induction motor can be changed by which of the following sequence? So the answer will be, it will be RBY. The flux always moves from the leading phase to lagging phase. The direction of induction motor depends on the rotating magnetic field. Therefore, by interchanging the two phases, the direction of the rotating field can be reversed. And this will reverse the direction of motor. So the answer will be B, that is RBY. Next, which of the following pair is or are correct? So the answer is open slot to leakage flux is less, closed slot to leakage flux is high, and semi-closed to leakage flux is moderate. We know that leakage flux is a machine will depend on the air gap between the stator and the rotor. If the air gap is more, the leakage flux is less and vice versa. And in the open slot machines, the air gap between the stator and the rotor is more, so the reluctance is high. Similarly, therefore the leakage will be less. In closed slot machines, the air gap between the stator and the rotor is less, therefore the reluctance is low. Therefore the leakage flux is high. In semi-closed type, the air gap is moderate, so the reluctance will also be moderate and the flux will also be moderate. Next, which of the following machines have the highest power factor with respect to magnetizing current? So the answer is, it is closed slot type machine. We know that operating power factor will depend on the air gap between the stator and the rotor. If the air gap is more, it will require more amount of magnetizing current. This will decrease the operating power factor and vice versa. In open slot machine, air gap between the stator and the rotor is more. Therefore, the operating power factor is poor. In closed slot machine, the air gap between the stator and rotor is less. Therefore, the operating power factor is more. In semi-closed type machine, the air gap between the stator and rotor is moderate. Therefore, the operating power factor is also moderate. So, the operating power factor is closed type machine is more than others. Next, which of the following induction motor has the highest starting torque? So, the answer is it is slip ring induction motor. Depending on the type of rotor used, induction motors are classified as squirrel cage and the slip ring motors. In the squirrel cage motors, it has low starting torque. By this formula, we know that it is directly proportional to E into I into R by Z. For high starting torque, requirements of slip ring induction, also called as wound rotor, are used. In slip ring motors, the rotor core consists of slots containing three-phase windings similar to stator. The rotor winding is essentially connected in star and three-phase terminal, and three slip rings which are mounted on the shaft. A suitable value of external resistance is added equally onto the rotor three-phase winding through stationary slip ring contacts known as brushes. Next, which of the following motors is or are widely used? So the answer is squirrel cage induction motors are widely used. We know that in slip ring motor, brushes are present due to the frequent maintenance it required. Therefore, the design is complicated due to the windings, slip ring and the brushings. Slip ring induction motor is comparatively having more weight than the squirrel cage motor. The construction of a squirrel cage is simple and robust, and it is cheap as compared to slip ring induction motor. Therefore, squirrel cage induction motors are widely used. Next, a 4-pole 50 Hz induction motor is running at 1470 rpm. What is the slip value? So slip is equal to ns minus nr upon ns, where ns is equal to 120 f by p. From here we can find out the ns, that is 1500 rpm, by just putting up the values of p, f. Now the slip will be 1500 minus 1470 upon 1500, which is equal to 0.02, that is b. Next, at standstill condition, the value of slip is, so it is 1. We know that ns minus nr upon ns, so ns minus 0 upon ns, that will be equal to 1. Next, a 4-pole 50 Hz induction motor is running at 1470. The frequency of the rotor current is, so we know the formula, that is slip into supply frequency. So slip is equal to 0.02 as we have found earlier in question number 112. So 0.02 into 50, that is 1 Hz. So the answer is C, that is 1 Hz. Next, the speed of rotating magnetic field of 8-pole 50 Hz induction motor is, so the answer is it is 750. How? 120 f by p. So just putting up the values, we get 750 rpm. Next, when the maximum starting torque is obtained, rotor power is, so we know the formula, that is torque at standstill is directly proportional to EI cos phi. So by using this formula, we know that maximum starting torque will be obtained when R is equal to X. That is, the rotor resistance should be exactly equal to the reactance at standstill. So the answer is 0.707 lagging. Next, the condition for maximum running torque is, so the answer is it is R is equal to S into X. That is, maximum running torque occurs when S is equal to R by X. So the condition for maximum running torque is rotor resistance should be equal to slip times the rotor reactance at standstill. Next, which of the following will vary the maximum torque? So the answer is it is rotor reactance. TR is equal to S into R upon में R plus JX का whole square. So the condition for the maximum running torque is R is equal to S into X. By substituting the above value, we can get the maximum torque. So T max is directly proportional to 1 by 2x. Therefore, the maximum torque will be depend upon the rotor reactance X only. So the resistance cannot vary the maximum torque developed in the motor, but the slip or speed changed due to the rotor resistance. Next, a motor operates in stable region at which of the following slip? So the answer is it is at the low slip region. The torque is directly proportional to slip only in the stable region, and it is inversely proportional at the higher operating slip. So the entire operating region is divided into two regions, the running torque and the low slip region. So therefore, under the low slip region, the motor operates in stable region. This is the low slip region, that is Sx is very much greater than R, and in high slip region it is less than R. Next, in circle diagram for the induction motor, diameter of the circle represents which of the following? So answer is it is dependent upon the rotor current. Basically, in circle diagram for induction motor, the diagram of the circle represents the rotor current. By using the circle, the current per phase will blocked rotor and the full voltage on the stator and the line current in amperes for any given load can be found out. Okay, so if you like my videos, you can also subscribe to my channel, and if you have any doubt, you can always ask me in the comment section below. Thank you.